that's number 3. All right, number 4. Mr. Worthington is looking for a new house. He has to put a $10,000 down payment and pay $1,000 each month. Write an equation for Y, the total number he will have spent after X months. So we're just writing an equation, okay? Y equals mx plus b. Mx plus b. So our slope, or what is going to be our constant or variable, okay? So variable is the same thing as the slope. Our constant is the same thing as the y-intercept. So the variable is what's going to go with the x. Is $10,000 getting down each month, or is $1,000 going down each month? It's the $1,000 each month. So that's going to be my variable. 1,000. $10,000 down is the constant, or my y-intercept. So 10,000 is what's going to go here. All right, equation for y. So now we just plug this in. So y equals 1,000 x plus 10,000. That's the equation. Oops. All right, there we go. All right. Okay, let's look at number 5. So use the equation you wrote in problem 4 to complete the table. All right, so what we're going to do is I'm just going to rewrite this equation. Y equals 1,000. I'm going to put in parentheses x plus 10,000. So what I'm going to do is I'm going to put this months in here for x. So this 0 is what's going to go here. So I'm going to erase this x right there. And then we're going to put in 0. So 1,000 times 0 plus 10,000 is what's going to give me the total cost here. So when I put that in my calculator, I get my total cost, which is 10,000, because this times 0 is 0. So 10,000 is what goes here. Now I'm going to substitute 10 in for 0. Y equals 1,000 times 10 plus 10,000. So that you can go ahead and put in your calculator. 1,000 parentheses 10 plus 10,000. Hit enter. You're going to get your answer, which is 20,000. I think you get the rest of the idea. So like this 20 is what's going to go next. That's going to be there. Okay. Y equals 1,000 parentheses 20 plus 10,000. So you just plug it in and go from there. Enter 20. This is going to be 30,000. Okay, you see the pattern. What's going to be next? 40,000. So that's what we got for the table. So kind of 4 and number 5 kind of went together. That's okay. All right. That's number 5. Okay, number 6. Can a number be both rational and irrational? Yes or no? So remember, to be a rational number, it can be a decimal, it can be positive, it can be negative. It can the thing that has to be rational is that means it has to have a terminating decimal, which means it has to stop. Has to stop. The decimal has to stop completely, or it can be repeating. Okay. To be irrational, that means that it has a number that goes on forever, and it does not repeat, does not have a pattern. Okay, so like pi is the most common irrational number, how that kind of goes on forever and doesn't repeat. So these are totally different. So can they number be both rational and irrational? That is no. Okay, they cannot be both. All right, not much with that. Not much work with that one. That's just easy. Okay, yes or no. Okay, but make sure that you do know how to differentiate why this answer is no. Okay. All right. Oh, number 7. What is the value of 10 to the 0 power? So remember, not any math to this one either. This is kind of we went over to the 0 power. Remember, anything to the 0 power is 1. So I'm going to kind of write that little note in here. Anything to the 0 power is 1. Okay, anything to the 0 power is 1, just so that you know. So you just put 1, that's okay. All right. So this one kind of is going to go into question number 8 too. All right, question number 8 gets us something with scientific notation. All right. We want to know the value of 4.83 times 10 to the 0 power. Okay, so if it's 10 to the 0 power, that means my decimal's not moving any. So if I'm going to answer this scientific notation wise, I would rewrite 4.83. Okay, and then I'm going to look. This is going to tell me if it moves. So is this decimal going to move any? No, it's not, because it's 0. If it was 1, then I'll move it 1 to the right. If it was -1, I'll move it 1 to the left. But this is 0, so that means it's not going to move. And this is also the same thing. 10 to the 0 power, remember we just said is 1. So 4.83 times 1 would be 4.83. So not much math to this one either. Like I said, some of these are going to be pretty easy today. All right, and that's okay. Kind of ease you back into it after being off for a week, right? So there we go. All right, number 9. Does the following mapping represent y as a function of x? So is this a function? So remember, we gotta look here. Okay. We're looking, let me kind of draw this in. I know it's kind of faded, it might be a little bit faded for you. Like that. There. And there. This is x. This is y. This is z. And that's w. Okay. All right, so remember, to be a function of x, to be a function, that means all these x values. Now I know this is x, y, z, and w, but these are my x values. Don't let that confuse you. Everything here is an x value. And let me, you know what I'm actually gonna do is I'm gonna circle that in blue. Oops, not highlighted blue. Circle blue. All these right here. So in order to be a function, each one of these can only have one y value. These are my y values. So see how this x only has 1. This y only has 1. Z goes to 1 and w goes to 1. Also, we said just look at these. If only one arrow comes out of these, then that's okay. 2 goes here, and that doesn't matter. Okay, that doesn't matter for the y's. But these x values right here, only one arrow is coming out of each of these. So this is, yes, it's a function. Another easy question for you, and hopefully you should get this right. I think y'all did pretty good with these functions. All right. Okay. Last one, number 10. Before I go on to number 10, I want to let y'all know that I'm gonna go back and look through the first ones. I kind of had this thing plugged in, so I'm gonna go back on the first few and make sure that the sound is on those. If not, then I'm gonna have to redo this, but it'll be the same thing. So, using the graph below, write an equation in slope-intercept form for the line. Okay, so I know this is kind of hard. There's no lines here really, and I know it's hard here to see where this thing crosses. But what I'm going to do is, or what we talked about me and Mr. Parent, is we are going to put a point there on the -7 and then here on the 2. Okay, I know this might be a little bit down, but I know some of y'all might not be able to see that. Okay, that's good. If you're in Mr. Lang's class, just tell him I'm sorry. I don't know if he is the same way or in Mr. Worthington's, but it's just blame it on me. You can blame it on me. I'll take the blame for that one. All right. So let me get. There we go. All right. So y equals mx plus b. So we need our slope and we need our y-intercept. If I'm going from down here, this 7. Remember, I'm going up. Okay. Am I going up or down to get to this point? I got to go up. So this is going up 7. So that means this is positive. And 7 is going to be my numerator for my slope. And then it goes over to the right 2. So that means my denominator is 2. All right. So 7 over 2, we can leave it like that. Okay, we'll leave it at 7 over 2. You can make it, if you made it 1.5, that's okay too. And then my y-intercept, I start from here and I go down until I get to that point, which is right there, and this is -7. So this is going to be -7. Once I have these 2 pieces of information, I can go ahead and write my equation, which y'all are getting really good at that, by the way. Y equals 7 over 2x minus 7. If you have this, 7 equals, I think it's 3.5 actually. 7 divided by 2. Yeah, 3.5. If you put y equals 3.5x minus 7, that'd be okay too. Either one of these. I'll box them in both. There. And then there. Okay. All right, like I said, I'll go back and check the first ones. Hopefully the sound worked on those. If not, I will go back and redo the first one at least with the calculator, because I think that's very important that you know those. All right.